How you doing, guys? This is your unit circle quick review. Okay, we're going to go ahead and just fill out this table using a unit circle. It's kind of how we did this in class. So let's just go ahead and get through this. I'm pretty sure I would have done this in class. So if you didn't catch everything I did, just watch this review video, and we'll just get started on this. Okay. So the first thing I'm asking for is all of these trig ratios for this particular angle right here, which is 5 pi over 4. So the first thing you want to do on every one of these questions, we'll just call it number 1, is to go ahead and locate 5 pi over 4 on a unit circle. All right, so if we just kind of sketch a Cartesian coordinate grid, I'm going to go ahead and figure out where 5 pi over 4 is. So if I imagine a half circle, remember we start here, which is 0 radians. If I imagine a half circle, we'll call that pi radians. Okay, now keep in mind, pi radians is the same thing as, remember, we're going to take a look at this denominator here, which is 4. And we're going to say, okay, if I put this over 4, pi would be the same thing as 4 pi over 4. Okay, because the 4's would just cancel out like this. So 4 pi over 4 is actually the same thing as pi. It's a half circle. Okay, so what you're basically imagining is that pi over 4 is a piece of space, right? And we have 4 of those pieces, 4 pi over 4. And that gives me that half circle. So there's 4 equally spaced pieces inside this half circle. Now I don't want 4 pi over 4 because I'm looking for 5 pi over 4, right? So if I imagine that, okay, so this is pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. 1, 2, 3, 4 pieces. I need to get to the 5th one, which is right here, so I can have 5 pi over 4. So basically what I'm telling you is that the angle 5 pi over 4 is actually this entire thing right here. That's the angle 5 pi over 4. All right. Now that's great, okay, except for that doesn't really help us answer the question, or does it? Because what I'm going to basically do here is figure out that from this terminating side, the shortest distance to the x-axis. Remember, this is an x-axis right here. X-axis, y-axis. Okay, so the shortest distance here is this angle here, which we call a reference angle. Okay, this is your reference angle. And if we go out to the circle and this point here, what I have now is a right triangle. Okay? And what this is telling me now, what I'm going to ask you, I guess, is what is this angle right here, this reference angle? Remember, this is 1, 2, 3, 4, 5 times pi over 4. So that means this reference angle right here, if I want 4 pi over 4 to get to this half circle, then I have to go 1 pi over 4 further. So this is pi over 4. This angle right here is pi over 4, which is the same thing as 45 degrees. You're supposed to know that. That's memorization here of the special triangles. So this is a 45 degree angle, and so is this one. So I guess the real question now is, what are the side lengths of this right triangle I've created? Okay, you should know the special triangles by now. Okay, and we're going to draw it over here so you can see it. An isosceles right triangle, where both of these angles are 45 degrees, you'll have the ratio root 2 over 2 and root 2 over 2, and this will be 1. Okay, so this is root 2 over 2, and this side is root 2 over 2. This side right here is also root 2 over 2, except these are both negative, because we're looking at this coordinate right here in the third quadrant. Both x and y are negative. So what I found here by doing this essentially is this x displacement here on the x-axis is the cosine of 5 pi over 4, and this right here, this y displacement, is the sine of 5 pi over 4. So I actually have these two answers for this one and this one. So the sine is the y value, which is negative root 2 over 2. The cosine is the x value, which is the same. It's negative root 2 over 2. And once you find sine and cosine, then the rest of this row is pretty much going to be easy to fill out, okay? Because everything is a variation of cosine and sine. So the first thing we'll find, well, the second thing we'll find after that is tangent of theta, remember? So the tangent of theta, remember theta being 5 pi over 4 after all, is actually the same thing as the sine of 5 pi over 4 divided by the cosine of 5 pi over 4. And because we just figured out the sine and cosine of 5 pi over 4, we're just going to divide this box by this box. So this divided by itself is actually the value 1. Okay? The secant, keep in mind, the secant of theta is 1 over the cosine of theta. So if I get cosine's answer, which is right here, I can just flip the numbers upside down, and that will technically be the same thing as secant. So if I go ahead and tell you that cosine theta is root 2 over 2, and I just take these two values and find its reciprocal, flip it upside down, then what I'll end up getting is negative 2 over root 2. Now this is technically correct, except you can't leave your answer like this. I won't accept it. I really don't want radicals in the bottom of your fraction. Conventionally we don't do that. So what I'm going to do is I'm going to multiply the top and bottom of this fraction by root 2 over 2. Top and bottom, okay? So let's multiply negative 2 by root 2, and that's going to give me negative 2 root 2. When I multiply root 2 by root 2, it'll just give me positive 2. And what I see here is that these 2's will cancel out, and now I just have negative root 2 as the solution. So secant is simply negative root 2. Now bear in mind I showed you all steps to do this. Ordinarily, I would just do this in my head. Many students can do this in their head once they practice this enough. So I showed you all the steps deliberately so you can see where it comes from. So that's what we do in these training videos. But in the future, you really shouldn't actually have to write out all the steps, and you can do it pretty much automatically. That's the idea. So I'm going to keep going with this. I'm going to give myself some space here with this eraser. All right, let's go ahead and erase some of this here. Okay, and then we're going to continue here. So let's go ahead and find the cosecant. This is the same thing. We're just going to take sine instead. The reciprocal of sine is cosecant. So we're going to take sine's answer and flip it upside down. Well, because we notice that cosine and sine are the same, we should get the same answer as we did for secant. So this is also going to be negative root 2. Okay? Alright, so the cotangent now is what we have. That's the reciprocal of tangent. Remember, tangent is 1. Okay? If I tell you that tangent of theta is equal to 1, which is the same thing as 1 over 1, if I actually take these values right here and flip them, I should get cotangent, which is still going to be 1. It's not going to change anything, so that's 1. And now I have cosine of theta minus pi over 2. Okay, for those of you who are not sure, pi over 2 is the radian equivalent of 90 degrees. It's the same thing as this pi over 2 right here. So what I'm basically doing is I'm looking at this angle here for this question, all the way over here, this angle, and I'm subtracting pi over 2. Okay, so let's actually draw a better sketch here for that so I can make this a little more clear. Let's get a really bigger eraser here. Here we go, that's fine. What I'm going to do is I'm going to take that angle I have, which is right here. This is 5 pi over 4. And I'm going to subtract 90 degrees from it. So I'm going to go backwards, going to go clockwise. When you subtract, you always go clockwise, 90 degrees. Remember, this now is a 90 degree angle, I'm telling you. But this we know is 45. So this one is also 45 degrees. Because this right here is your what? Is your 90 degree angle. So now I can think of a reference angle as being this angle right here, just this angle right here, and I now have a what? A right triangle again. That's a 45, 45, 90. So what you will see here is actually this side length here is still going to be negative root 2 over 2. But this time this side will be positive root 2 over 2. I'm only interested in this side length right here, which is this portion right here, because that's the cosine that I want, which is what I'm asking you for. So it's negative root 2 over 2. And that would be that answer. So we've actually completed this question. There's only 6 questions. That's one of them. So like I said, this video shouldn't take very long. because these questions aren't very difficult once you get the hang of it. So I'm just going to keep erasing. That's what I'm going to do every time we have a question. So let's do the second question. Let's go back to here. And we're okay. Okay, the next question is negative 7 pi over 6. Remember, the first thing that you do is you locate where that would be on a unit circle. Okay. This angle is negative, right? You can see this. This angle is negative, which means I have to measure it clockwise from the positive x-axis. So this is the positive x-axis, and I'm measuring it clockwise. If I were to, in fact, go a half circle, I would end up at pi, at negative pi radians as a half circle. That's the same thing if you pay attention to your denominator as negative 6 pi over 6, because here we would see what? The 6's would just cancel. So I am traveling 6 spaces. Remember, think of a space as being pi over 6, and this is 6 of them. So there are 6 evenly spaced segments here that are called pi over 6, and I've gone a total of 6 different spaces. But I don't want to go 6 spaces. I want to go to 7, right? Negative 7 pi over 6. So I need to go an extra space. So I need to go a little further, because I don't want to stop just at 6. I need to get all the way to negative 7. So I need to go all the way through this far. Okay? And what I'm seeing here, when I do that, this is where I'm going to stop right here. But this creates a right triangle. That's the idea. And what I need to figure out is the shortest distance from this line where I stopped at to the x-axis, and this is called a reference angle right here. Okay, if this is 6 pi over 6, then how much further do I have to go to get to negative 7 pi over 6, which is this big angle that I'm reading right here? This is what I'm telling you. This is negative 7 pi over 6. How much further did I have to go beyond a half circle? I had to go pi over 6. This particular angle right here is pi over 6, because that's how much further I had to go. That's a reference angle. Technically, the reference angle is always positive, so you shouldn't say, well, that's a negative pi over 6. You know, that's what you add a negative 6 pi over 6 to get there, but technically you should think of this as a positive quantity. Pi over 6 is the same thing, of course, as 30 degrees. So this is another 30, 60, 90 triangle that I'm glaring at right here. Okay, and you need to be clear on that, and this is really not that difficult. So we have this, and this is a 30-degree angle, which means this is a 60-degree angle, and this is a 90. So this, we know the distances here from that special triangle that I keep drawing. Okay, if this is 30 and this is 60 and this is 90, this is root 3 over 2, this is a half, and of course this is 1. So I'm going to put those corresponding sides here. This is a 30-degree angle right here, so this is going to be root 3 over 2. But in the second quadrant, the x value, since this is an x displacement, will be negative. And up here, as we go up this direction, this will be a positive 1/2. This is the cosine. The x's value here is the cosine of your angle, and here is the sine of your angle. So I have these two answers. The cosine is the x, which is negative root 3 over 2, and the sine is the y, which is 1/2. That's what I'm getting from here, these two values. So let's keep moving. The tangent, of course, is what? It's y over x, or you can call it sine. Sine divided by cosine. So it's 1/2 divided by negative root 3 over 2. So we'll find that. The tangent theta is equal to my 1/2 divided by negative root 3 over 2. Okay, this is the same thing as what? Your sine divided by your cosine. So I'm going to go show you all the steps here again, because I want to make sure you know how to do this. Some people can do it in their head, some people can't. If you can't do it in your head, write it on the paper. Okay, you don't get extra points for being able to do it in your head. The most important thing is that you get the answers right. So what I'm going to take these two, take this fraction here on bottom, and I'm going to flip it upside down. It's a reciprocal, is what this is called, a negative 2 over root 3. Multiplying by the reciprocal of the bottom is the same thing as dividing by that fraction. So let's take a look at this. We're going to see 1 times negative 2, which is negative 2 on top, and then 2 times root 3, which is 2 root 3. And what you should notice is that these 2's cancel. So this is negative 1 over root 3. So if I have negative 1 over root 3, okay, we're just going to carry on over here. I can't leave this radical here, so I'm going to multiply the top and bottom by that root 3. Negative 1 times root 3 is negative root 3. and root 3 times itself is just 3. So this right here is your tangent, okay? And with practice, negative root 3 over 3, with practice, you should be able to do that in your head, okay? If you practice it enough, that should be what's happening. Okay, let's go ahead and erase this portion at least, because I don't need anything else. Let's find the secant. Okay, so we're going to say the secant is the reciprocal of cosine. All right, I'm going to write that here. Secant theta is the reciprocal of cosine. Oops, cosine theta. So secant is the same thing as cosine. We're going to take cosine's answer right here. We're just going to flip the numbers upside down. So when I say that, okay, if cosine is negative root 3 over 2, if we flip it upside down, it's negative 2 over root 3. So what I need to do is simply multiply top and bottom by root 3. Negative 2 times root 3 here times here is negative 2 root 3. And then this times itself, root 3 times root 3 is just 3. So this is your secant value. Okay. All right. The cosecant is the reciprocal of sine. If I flip 1 over 2, I'll just get 2 over 1, which is the same thing as 2. That's the answer for that one. Very straightforward. The cotangent is the reciprocal of tangent. I could technically take this answer for tangent and just flip the numbers, okay, on the fraction and then simplify it. That would give me the correct answer. Another way of doing that is cotangent is the same thing as cosine divided by sine. So I could take this answer here for cosine and divide it by the answer for sine, which is actually what I'm going to do so I can show you that. So the cotangent is the cosine over sine. It's a trig identity. And this is going to be negative root 3 over 2 divided by a half. Remember, when you divide by a fraction, you're multiplying by its reciprocal right here, okay? And what you notice here is that the 2's are going to cancel. So what I have now is negative root 3 on top, and then I have a 1 on the bottom. So the answer is just negative root 3. Negative root 3. That's the cotangent. Okay, and we're almost done with this question. And again, there's a reason this is really taking even as long as it is because I'm explaining everything. If you were to just go through this test or this review without all the explanation that I'm offering, this will not take near as long. Okay, so cosine of theta minus pi over 2. Okay, keep in mind that theta is this angle right here, which is negative 7 pi over 6. I want to emphasize that, negative 7 pi over 6. What I'm asking for is theta minus pi over 2. So I'm actually going to subtract, okay? I'm going to subtract pi over 2 from this. Oops, don't do that. Let's erase all these mistakes, right? Minus pi over 2. Okay, I need a common denominator to subtract fractions, so I'm just going to multiply the top and bottom of this by 3. Okay, so what this is going to give me is negative 7 pi over 6, and then 3 times pi, which is 3 pi, and then 3 times, of course, 2 is 6, so I have a common denominator here. Negative 7 pi minus 3 pi is negative 11 pi over 6. Technically, that's the new angle that I want you to explore. All right, what I'm actually doing on the diagram right here, since this is where I am right now, this is the angle that I'm looking at, I'm going to move a little further. Let's change the color up here. Let's change it to green. I'm going to go about to here because I'm going to go 90 degrees further. I'm keep going clockwise because I'm doing what? I'm subtracting this pi over 2 right here. I'm subtracting it. So this is what the angle, the new angle that I want you to be evaluating, and this angle here, this green angle, is negative 11 pi over 6. That's technically what's happening because we're going 90 degrees here further. Okay, so what I can see here though is that this makes another triangle again. And this is my reference angle. This reference angle right here, because this is negative 11 pi over 6, this is the same thing as pi over 6, because that's how far I have to go to get to negative 2 pi. So right here, we know this angle is going to be the same thing as 30 degrees because it's the same thing as what? As pi over 6. Okay, so there you go. If that's 30 degrees, this is 60, and this is 90. So now I know all the side lengths of this. I ask you only for the cosine, which is the x, okay? That's the x value. So if I know this x value, remember from the 90 to the 30, that's what? Root 3 over 2. It's the same thing here. It's root 3 over 2. So this is going to be your answer for this particular box right there, okay? That's how it works, okay? I hope you understand that, okay? To emphasize this again, this is so important. How did I know this angle? Because if I went an entire circle all the way through, that's negative what? 2 pi going in the clockwise direction. Negative 2 pi is the same thing as negative 12 pi over 6, because 12 divided by 6 is 2. That is a full circle. I did not want to go all the way a full circle. I only want to go this far. I'm not going 12 different pieces of this pi. I'm only going what? 11 pieces. So I stopped here. I know this extra piece here has to be the same thing as what? As pi over 6. That's how much further I had to go to get to that complete circle. So this is the reference angle that we're using to make this what? This triangle. That's how I knew that angle was going to be pi over 6. That's my explanation there. Okay? It's a good way of looking at it. So let's go ahead and erase all this right here, and then we'll start the next question. Alright, let's just use purple here. So we're going to say number 3. This is 540 degrees. This is a very simple question. Okay, so we're on degrees now because we've been using radians. So let's take a look at this, and we'll put the x-axis down and the y-axis. Okay, very straightforward. And let's change this color up. All right, so this is a positive angle, which means I'm going to measure it counterclockwise. We're going to start here, and I'm going to go this way. This is a half circle, which is what? This is 180 degrees, and then I keep going. This full circle is 360, but then I must keep going because I'm not stopping at 360. I have to get to what? 540. Okay, now I want you to keep in mind that 540 minus the 360 that you already had, kids, remember, is going to be what? 14 and 6 is what? 14 minus 6 is 8, okay? And then 4 minus 3 is 1. This is a half circle. This is 180 degrees. That's what we're going to get. So we just need to go 180 degrees past 360 to get to what? This angle here is now 540, okay? So let's wrap it all the way through. This whole thing is what I mean by this is 540 degrees. But where do I end? I end here. And on a unit circle, I know this coordinate is going to be negative 1, 0. Negative 1, 0. Cosine of 540, or that theta angle, is given by this x value. Okay? And the sine of theta is given by that y value. So I know the cosine and the sine of 540 already. It's going to be negative 1 and 0. So I can put that in my table. This is negative 1 and 0. Now that I have these two, I can go ahead and finish the rest. Tangent, as we know, is simply the sine over the cosine. I can see that this is 0 divided by negative 1, which is going to be 0. So that's the answer for tangent. The secant is the reciprocal of cosine. So if I say cosine is negative 1 over 1, and I flip this upside down, I'll still get what? I'll still get negative 1 over 1. So this is the same answer as cosine itself. It'll be negative 1. That's secant, okay? Cosecant is the reciprocal of sine. That's a little tricky. I just told you that the sine here is 0. Okay, sine of theta is 0. But that's the same thing as 0 over 1, technically. If I flip this fraction upside down to get cosecant, what I'm telling you is that that's 1 over 0. Everybody should know by now that you can't divide by 0. Even a calculator would give you fits over that. So this really you cannot do. This is actually undefined. Okay, so this cosecant is undefined. All right. Cotangent. All right, cotangent. Let me get an eraser here. I'm taking up a lot of space, as I usually do when I show all steps. All right, let's see what we have. Let's change my pen to blue. It's fine. So cotangent, we're going to basically say cotangent is the reciprocal of tangent, which in turn is the same thing as cosine over sine. So I can take the cosine answer and divide it by the sine. The cosine is -1, sine is 0. So that's basically like saying -1 over 0. Again, we see the same instance here. We can't divide by 0. That's undefined. So this is undefined. It is not uncommon at all. If this is undefined, you're probably going to be expecting this one to be undefined as well. The cosecant and the cotangent, based on the relationship that they have. And now we're on to the hardest part, where I do this little transformation here. This is a phase shift on the graph of pi over 2. So what I'm going to do is I'm going to subtract 90 degrees. That's what pi over 2 is. Remember, I'm right here, and if you subtract, you actually go clockwise, always clockwise when you subtract. So I'm going from this point right here clockwise and going back this way by a quarter circle. So now I'm actually right there. I've gone this direction. Okay, I've gone this direction from here, and now this is where I am now. So this coordinate on a unit circle at the very top will be 0, 1, 0, 1. That x value is your cosine. That's your cosine of that new angle that we're looking at here. So here, the cosine is what I'm asking you for, of course, so that cosine answer will be 0. That's it. Okay, we actually have finished half of this review. And remember, the only reason it's taking so long is because I'm explaining everything. Okay? So, like I said, this is not really how long it should actually take to complete without the explanation. So let's do number 4 here, which is 13 pi over 6. This requires careful explanation. Identify where that angle is. Okay, positive angle, so I'm measuring it counterclockwise. Start at 0. If I go a half circle, this will end at what? At pi. If I keep going full circle, that'll be 2 pi. But 2 pi is the same thing. Keep in mind with this denominator is the same thing as 12 pi over 6, because 12 divided by 6 is the same thing as what? As this 2 right here. So I'm saying pi over 6 is some sort of space, an angle like this. That's pi over 6. But I'm going to go how many of those? This distance is pi over 6, but how many am I actually going to go? To get a full circle, I'm going to go 12 of them. Okay, so that'll give me all the way back to a full circle. But I don't want to stop at a full circle, because I need to go beyond that. I need to go beyond this full circle. I need to keep going further. But by how far? By one more, because I already have 12 through there. I just need one more to get to 13. So this is what I'm looking at here. Okay, I'm looking at this particular, let's put it in a different color that you can see. That's where I'm going to stop. I'm going to stop on this particular line. I'm going to stop here, because I've actually measured this angle all the way around and back. Okay, here's 12 pi over 6. I just had to go a little further. How much further did I go? Okay, what do I have to add to 12 pi over 6 to get to 13 pi over 6? That's the real question. If that's 12 pi over 6 right here, how much further do I have to go to get to 13? This angle, that reference angle, is telling you that must be what? Pi over 6. Because if I add pi over 6 to 12 pi over 6, I'll get the what? The 13 that I wanted. So now I have a triangle again. And this is 30 degrees, because pi over 6 is 30 degrees. So this is a 30, 60, 90 triangle. Remember, you're always going to see the 30, 60, 90 or the 45, 45, 90. Okay, so this right here, this distance right here, is what I'm looking for, and I know the ratio of that triangle should be what? This distance should be root 3 over 2. It's positive. Okay, so that's what I'm saying. That's the cosine of that angle, which is root 3 over 2. The sine is this y value that I now know, which is a half. So that is the sine. It's a half. Once I have those two, it's going to open up a lot of doors for me. Okay, so that's the idea. I really don't want to erase that, actually. I want to keep that there. But I do need to figure out what the tangent is. So the tangent, again, the tangent, you should always think of it as being sine over cosine. It's true. This is a factual statement there. The sine value we know is a half. That's the y value, this y value that we got. We're going to divide it by the cosine value, which is root 3 over 2. Showing you all the steps. When you divide by a fraction, you multiply by its reciprocal. So the reciprocal of the bottom is 2 over root 3. We ignore this. 1 times 2 is 2. 2 times root 3 is 2 over root 3. These 2's will cancel, which gives me 1 over root 3. And then to simplify it and multiply top and bottom by root 3. 1 times root 3 is root 3. And then root 3 times itself on the bottom is just 3. So that's your answer for the tangent. Keep in mind, all this should be able to be completed in your head with practice. If you can't do it for this test, don't sweat it. You can write it all out. I just want you to get it right. Okay, now let's do this. We're going to go ahead and do the secant. The secant is the reciprocal of cosine, as we all know. So we could take cosine's answer, which is root 3 over 2. It's like saying 1 over root 3 over 2. See what I'm saying? Cosine is root 3 over 2, so we say 1 over that. When I do that, this is going to give me 2 over root 3. And then I'll have to multiply the top and bottom by root 3 again to get rid of the radical on bottom. 2 times root 3 is 2 root 3, and then root 3 times itself is 3. And that's your answer for the secant. 2 root 3 over 3. Very well. The cosecant. Keep going through this, all right? This is nothing. It's nothing. Cosecant. Cosecant. Okay, cosecant theta is the reciprocal of sine. It's 1 over sine, which is like saying 1 over the sine right here, which is a half, which is now just what? It's just 2. Okay? That's what that is. The cotangent, let's erase this portion over and over. Alright, let's see. The cotangent, if tangent is sine over cosine, then cotangent is cosine over sine. So here's cosine, which is root 3 over 2. We're going to divide it by the sine, which is 1/2. So let's change the color up really quick, and I'll do it in blue. We're multiplying by the reciprocal of the bottom, which is 2 over 1. What you should notice is that these 2's will cancel, so it's root 3 over 1, which is root 3. That is your cotangent value. Showing you all steps, all intermediate steps. And then we're finally in the last question. So this is getting kind of messy, but remember that we are subtracting 90 degrees from the angle that we have. So we're subtracting 90 degrees. So we need to go from where we are here 90 degrees further. So I'm going to come all the way down here, because this angle here, let's do it in black or something so we can see it. This angle right here is 90 degrees. That's what I'm telling you. This is where we started. This is where we're going to finish. Okay? If this angle right here, though, is 30 degrees, if this angle here is 30 degrees, that means what's left here is actually 60, because 60 plus 30 is 90. So what I actually have now is a new triangle that has a 60-degree angle. Now this is 30, and now this is what? A 90. And I know these side lengths again. Okay? So let's clean it up, since it's getting tough to read. Alright. Just going to kind of redraw that so you can see what I'm doing. There we go. As now this is a 60 and a 30 and a 90. So this distance here I now know is a half. from knowing the sides of the special triangle. And this will be a negative root 3 over 2. That's the coordinates of this. So this is the cosine answer that I seek, because that's what I'm asking you for. So that's the answer for this question. All right. 2 more, nearly done. Okay. 2 more, nearly done. All right. Sorry, I'm changing the pen so much, but I have to. All right, number 1, 2, 3, 4. This is number 5. Negative 405 degrees. Negative angles are measured clockwise. This is a complete circle, which is negative 360. So if I go further, negative 405, say 405 minus 360, I can see that's actually 45 degrees. So I need to go 45 degrees further in the clockwise direction. So if I go 45 degrees further, I'm going to end up there. And let's draw this. I'm going to show you what I'm actually doing. I started here. I went all the way around. That's a full circle. And then what? I stopped here. That is what I'm looking at. That angle right there. Alrighty. So I have this new right triangle. And because I know this calculation here, I subtract this reference angle that I now know is 45 degrees. And this is what? 45 degrees. So now I'll know all the side lengths. This is going to be negative root 2 over 2, and this is going to be positive root 2 over 2. It's a 45, 45, 90 triangle ratio. Alrighty, so we know that the cosine is root 2 over 2, and that the sine is negative root 2 over 2. The tangent is the sine divided by the cosine. Divide this by this, it'll give you negative 1. The secant is the reciprocal of cosine. Okay, the secant is the reciprocal of cosine. So what I'm going to do is I'm going to say, okay, if I take the cosine value, which is root 2 over 2, this thing right here, flip it upside down, it's going to give me 2 over root 2. Alright, so now I'm just going to multiply top and bottom by root 2 to simplify it. 2 times root 2 is 2 root 2. Root 2 times itself is 2. And what you notice here is that what? The 2's cancel on the top and bottom. So it's simply root 2. That's the secant value. Alright? Cool. Now we're almost done. Let's go ahead. I'm going to go a little faster, I think, so we can get finished here. Alright, so the cosecant, we see the same thing. We're going to flip the sine value. These are the same cosine and sine except for one thing, that little negative sign. So you'll get the same answer except it'll be negative. Okay, same process. Cotangent is the cosine divided by the sine. So it's going to say this divided by this, which will give you negative 1. It's just the same two things, except one of them is negative, the other one's positive. Alright, so we're going to keep going. On the last portion of this, we're going to subtract 90 from where I am. This is 45 degrees. If I subtract 90, I'm going to go clockwise still. So I'm going to go all the way over here. This is a 90-degree angle is what I mean by that. Okay, but if this is 45, this right here is also 45, which means this one right here is also what? 45. So which means this one here is also 45. This is 45, 45, 45, 45. What I need to do is go to where I'm ending, and I go straight to the x-axis, shortest distance. This is the triangle I will use right here. This is my reference angle, which I also know is what? 45 degrees. And this is also 45 degrees here. So now that I know that, I can figure out the side length with the same ratios. This is going to be negative root 2 over 2. That's the answer for this. Okay? Negative root 2 over 2. That is your cosine value. So that's that answer. Last question. Last question. Let's just get the eraser. There we go. And do that. Okay, let's go ahead and do that. And we're on number 6. This is going to be negative 5 pi over 4. I like to use negative angles just to keep you honest. We have negative 5 pi over 4. We're just going to go ahead and locate that on the unit circle. It's a negative angle, so we're going to measure it clockwise. So we're going to say, okay, I'm going to go this direction with it. Half circle is going to be negative pi. Negative pi. And that's the same thing as negative 4 pi over 4. Negative 4 pi over 4. Because these 4's would what? Cancel, giving you the pi that you wanted. So, it's amazing how messy that gets really quick. I need to be able to see that. So, let's rewrite it real fast. This is negative pi, which is the same thing as negative 4 pi over 4. This is 4 different segments. There's 1, 2, 3, 4. 1, 2, 3, 4. That's how many I need to get. Each segment is pi over 4, and there's 4 of them. I don't need to stop at negative 4. I need to get to what? Negative 5. So I have to go 1 further. Keep going. So this is actually negative 5 pi over 4. But now that I know that, that's really nice because let's not use red. Let's use black here. Now I know this angle here because it's also what? Pi over 4. It's just another one of them. So it's the same thing as 45 degrees. This is 45 degrees. And this is a 90-degree angle. I know this here is negative root 2 over 2. And this here is positive root 2 over 2. That's the sine and the cosine. So the sine is root 2 over 2. The cosine is negative root 2 over 2. The tangent is sine over cosine, which is negative 1. Secant is the reciprocal of cosine, which is now negative 2 root 2 over 2, right? Which is the same thing as negative root 2. The cosecant is the reciprocal of sine, which is 2 over root 2, which is the same thing as 2 root 2 over 2, which is just positive root 2. Positive root 2. Cotangent, the reciprocal of tangent is negative 1. And here I am. And the last question is to keep going clockwise here to make a 90-degree angle. This is 90 degrees right here. And what we're going to do is we're going to say, hey folks, we know that reference angle now. That's also what? 45. So this is root 2 over 2 and root 2 over 2. This is the cosine I wanted, so this is root 2 over 2. That's your test review. I do hope you understand that. Okay? Watch this video carefully. If not, get help from someone. Watch YouTube videos. Do something. Please figure it out. Okay? It's really imperative that you understand because this doesn't go away, afterwards. But I appreciate you watching. I hope that's helpful. Good luck on your exam, and that's it. Good luck, guys.